Okay, so adding in a marker. Rust is awesome. Yes, I agree. Rust is pretty awesome. It's my current favorite language to sort of work in. Although I'm not working in like, you know, for a day job, so maybe that would change if I was actually being paid to as a day job to do this. So I don't know. We'll sort of like see how we feel about it once it becomes like an actual thing we do. All right. Is it evening for me? No, it is morning for me. It is 7:01 a.m. All right, so we're going to bring in GGEZ. And so in our main function here, we're going to gmain. And then our crate name here is object pool Rust. And this is learning object pool in Rust. And that's it for our main here. I'm probably gonna need to pass in the context because that's something that I'm sort of like feeling that is I'm doing more and more these days with like that initial setup, like the when I'm creating the game state. So it'd probably be good to set that up. Let's go over to lib.rs and glib. Did I make a Reddit clone? I know, I think I made a Reddit clone a long time ago. But I don't think it was in Rust or anything. I think I did that with like I don't even know if I did that on stream. Like I made maybe I did like that, or I did like a Twitter clone or something like that, PHP and Laravel. That was a long time ago. I don't remember. It was over a year ago, I think. I don't remember too much about like what entailed that project or how much of it was. I know that I've been requested to do like to continue and like finish, or at least to get further along in like how to build like those type of things. All right, so we've got you, and then you should be happy again. You're not, because I need to restart the Rust server. So you can re-index and discover that we actually have, like, our own crate exists. And you can get this out of there. Now, if I want to pass in the context here, we're already making this, let's see. Yeah, mute match. So I can just pass in context. And then I want to unwrap this. Now, of course, it's going to say, hey, it doesn't take into context, and it doesn't need to be in rep because it's not returning a result. But we're going to change that really quickly here. So in new, we're going to take in a context, which is a mutable reference to a context with a capital C. And we're going to return a game result, which has a game state inside of it, which means this needs to be wrapped with an OK. All right, and that should make it. Yeah, we have just two errors, two warnings, but no errors. So now we can actually do the things we want to do. For example, we're going to want to store in the well, maybe before I do this, I should run it to make sure it's working. So let's do a cargo run here. Compile everything really quickly. Every time I do this, I'm so much happier I'm on a desktop now. The notebook that I had is just like, I could actually talk and you can watch, and the CPU is not pegging to like 90% and the frames per second is staying the same. Oh, it's so nice. All right, so we get our basic sort of game window here. Cool. I totally don't need you to play the game. Let's see. What was I doing? Now let's create the mesh for our particle. And we're only gonna have like a single particle. So I think it is perfectly fine to store the mesh in the game state here because it's gonna be shared by every single particle. And it's either that or I'm gonna, well, I could also like give ownership over it to like something else. But let's go ahead. My initial thought is to create it and store it in here. So this is gonna be our particle mesh is gonna be a mesh. So GGEZ graphics mesh, and then we're also gonna need the mesh builder. Okay, so there's the mesh. Inside of here, we're gonna create that. So let particle mesh equals mesh builder new. I'm thinking this can just be a plain and simple circle. We need a draw mode. We need a draw mode. We need a point. For the location, we need a radius, that's just number, the tolerance, that's just number, and we need a color. I'm actually thinking we could make this color white. That might be easier. All right, so let's give ourselves a draw mode. So draw mode, this is gonna be a fill. Our point. So we're gonna do a point to new. And I'm gonna say that this is 0.0 and 0.0. So we're gonna start I know it's gonna be in like the top left of the screen, but we're gonna translate that over to where we really want it to be constantly moving. So that way we can only create this, we don't have to recreate the mesh every single frame. We just, place copies of it around or instances, references it all around everywhere. And then radius. Radius, what radius do I want this to be? Maybe something like a 5.0? I don't know. That might be too large. Tolerance. Tolerance for circles is like how many points do I want around it? So if I do less tolerance, it's going to be like less of a circle and more of a weird octagon or something. I'm gonna say like 0.1. So yeah. And then finally, our color. Let's make this white. So that way, if I want to overwrite the color, I can. Then we'll build this, pass it in the context, we'll question mark it, and semicolon. And that will, that is our particle mesh. So now we can pass this in here, like that. And now all it's doing is it's yelling at us that we're not actually doing this. So to show this on screen, I can very easily just do a graphics draw. Here we need the context. The drawable, so it's gonna be a reference to self.particle mesh. And then the draw params, so we need those two. Okay, draw param new, and then I want to move it to like a new destination. So our dest, let's move it like just, I don't know, not necessarily into center. We'll just say 200 pixels X, 200 pixels Y. I can also like set the color to be like, red or something. So we could, if we have a color in here, this takes a new color. So a new color, and we're gonna do 1.0, 0.0, 0.0, 1.0. And then question mark, semicolon. And then that is actually drawing that out. What are you upset about? Expected 1 argument, found 2. Drop param. Wait, new expects an argument? Or do I want to use default? What is the... Oh, what's the argument that it wants? I know it's drop param. Let's see, we create the default and then we're able to update the default with that, and that should return what we want from this. Let's run this and actually get the real error. Oh, right, there's no... That clear thing doesn't exist. Okay, so expected 1 argument, dest. Oh, I get it. This needs to be a point. A point to new. That's my problem. It was not drop param that's yelling at me, it's dest that was yelling at me. Okay, so now if I run this, here's our particle. So it's 5 pixels, it's a circle, and it's very bright red. But that should be very easy for you to see. I am gonna need to figure out later to like make that not happen, because when I'm like bringing this up over and over again, that is gonna get kind of annoying. Okay, so now that I have like my particle and I know exactly what I'm gonna do with it, it's time for us to delve into what this pattern was and start building it out. So let's go to our sample code here. So we're gonna have a particle, it looks like, and its suggestion was that we just have it live a certain number of frames. It could also live like a certain number of seconds. It could die as soon as it goes off screen. I think a certain number of frames is probably fine. Wait in it. Okay, so then we have initializer. All right, I think we can do this. So we're probably gonna end up moving our mesh inside of this particle. So that way it can handle drawing itself as well to the screen, which is probably pretty nice. Let's go ahead and create a new file here. I'm gonna name this particle.rs. So this is gonna be a pub struct particle. So we know we're gonna have a mesh, which is gonna be a mesh. So we need to now store that. Use GGEZ, graphics, mesh. Well, we also know we're gonna need that mesh builder. In order to do that, let's see, what else do we know we need for this? We know we need a color, draw mode. We know we need a game result. Let's use GGEZ. Also the context. So we need a context, game result, just to store our mesh for us. What other things do we really need for this? Well, we're gonna need a location. So they're using just like the X and Y separately. I'm thinking we're gonna use that in algebra 0.2 to store the location, because we just need it there just to tell GGEZ where to draw it anyways. So we might as well, instead of just having to constantly recreate it over and over again. So use GGEZ and algebra 0.2. So we're gonna have a location, which is a 0.2, which holds F32s. We probably also want to hold, well, we want to hold the color too. So what is the color of this? That's gonna be a color. That way we can have different colored particles too if we really want to. What else do we need from this? Frames left. So how many frames do we have left? And this can be anything that we want. So we can do this as like a a U32. I don't know how many frames we want it to survive. So we have the X and the Y. Oh, the X velocity and the Y velocity. So we can have this just be a point as well. It'll make it a little bit easier for us to do the math. So we can just store this as a point velocity. So a velocity, which is a 0.2 F32. And then the lifetime, well, actually that's going to be the same as the frames left. There's the X and the Y, the velocity, the frames left lifetime. In use is actually going to use frames left to determine that, so we don't need the flag. And that's pretty much going to be it for like what this particle stores. So let's go ahead and implement the particle pub function new. We know we're going to need to take in a mutable reference to the context. And at that point, I don't think we need to care about like the location or anything else. We're going to let ourselves deal with that. So we're going to return a game result that holds a particle. All right, so let's first create that mesh. We can do that by just stealing this from here. So this becomes our mesh. And at the bottom of here, we can return OK. Particle mesh. All right, that's first step is done. Now our location, what's next? So let our location, where do we want to be? For right now, I'll just set it at maybe the center of the screen. Let's do that. So in order to set it at the center of the screen, I also need to know what the width and the height of the screen is. So let's do that. Which means we need graphics. So graphics out of here. Let screen width, screen height equals graphics, drawable size, pass it in our context, and now we have F32s of our width and the height. All right, so set location equals a point to new, and I just want this screen width divided by 2.0, screen height divided by 2.0. All right, that gives us a location now. I'm typing faster than Rust Analyzer can keep up with me. Also, I have this error, so let's go and figure that out. Particle mesh, we're not storing you anymore like this. So that makes it happier. No particle mesh on game state, so we don't want to do this draw here either. Let's go ahead and just get rid of you. And you. There we go, no more errors. Now you should be able to properly autocomplete for me. Okay, so we have our location. Let's set our color. So let color equals color new. Now these are like RGB from like 0 to 1. We know that the alpha we want is to be 1, and we can make this like any combination that we want. We can like continue it with a red for right now. But I foresee us bringing in rand and then making random colored particles, which would be really fun. Okay, so we create a new color for here. And so we're gonna store that away. Frames of, you know what? It also might not be doing autocomplete for me because it doesn't think that it's part of this project. So let's go ahead and use the module system to bring it in. So we're gonna do mod, this is particle. And then down here we can do use particle particle. There we go. Okay, so we've got our particle. Now, if we wanted to like test things out, we could actually store a particle inside. So this would be a just a single particle, which is a type particle, and we want to create that. So let particle equals particle new, pass it in the context, question mark this to forward the error on up, and then store this in here. All right, so then shouldn't have any errors. We have 5. Now, okay, now we're getting our errors and autocomplete in here. Okay, that's what I need to do. All right, so we have color. Now we have frames left. So let frames left equals, let's just do this as maybe like 500 frames. And then our velocity. So let velocity equals 0.2 new. And we want this to be moving upwards. So I'm gonna say that this is not gonna move left and right at all. We're gonna be moving at a rate of -1.0. And so now we can store our frames left and velocity. All right, I like that. Okay, so this is good for just doing this. Let's also have a method in here to draw the particle to the screen, which should help with us actually like testing out, like, because we just wrote a bunch of code. We should like test to make sure it works. So pub function draw. What do we need? So we need a reference to self so we can access all this stuff. We need context to draw. So context. So we need a little reference to the context. And I don't know if we need anything else. We do need to return a game result, but we don't need anything inside of that game result. And this is going to be what we did before. So we're going to do so do we have graphics? We do. So graphics, we're going to do draw, and then hand it that context, reference to self.mesh, and then our draw params. So that is right here. Draw param. Okay, so we're going to create a new draw param. Then we're going to have a dest and send it to self.location. We want to set the color to be self.color. And I don't think there's anything else we really have to care about with this. There we go. We have mesh location color. So we set the color and the location, and that's pretty much it. And now here in the main library, we can go to draw and do self.particle.draw, pass it in the context, question mark, semicolon. And that makes it a lot simpler. We can also get rid of some of these things that we're not using actively. So all these sort of yellow, we're not using, so we don't need. And that will make those warnings go away. Now we have 2 errors. Cannot find value white in this scope. Where is that? Okay, so we need to pull in white off of graphics. Like that. That'll make that error go away. And field is never read. So it's just yelling at us that we haven't used these fields yet, but we will. Let's not worry about that right now. Let's go ahead and run this. And there we go. We have a particle in the exact dead center of the screen. Perfect. Next up, we want a particle system. So we have our particle. We can add this in. We're gonna have animate. Okay, we need an init method, an animate method, and an in-use method. Okay, so let's add those in so we can get like the movement and make sure those are working. ZX Sap, good morning. All right, so pub function animate. So this is gonna be mute self. I don't think we're gonna need context. This is gonna be pretty simple here. We're not even gonna return anything. What we are gonna do is we're gonna say that our velocity is added to our location. So self.location.x plus equals self.velocity.x. Self.location.y plus equals self.velocity.y. And that will make it sort of move upwards. And we can do that with, in update here, we're gonna do self.particle.animate. If I run this, we'll now see our particle moving upwards. Perfect. What is next? Oh, an init. I forgot about init. Let's do this near the top. So pub function init. So mute self, because we are going to be changing ourselves. And then we're going to want to like take in all of this stuff that we had before. So we want to take in, we could take in like the X, and then create the point from that. So is an F32, the Y is an F32. So that's the location. The mesh is going to stay the same. The color, so we probably want a color, which is a type color. Or maybe we could have this be random eventually. So maybe we need a color. The frames left. What were we doing in here? In it was X and Y. Oh, the velocity. It's like which direction is it going to be going? And the lifetime. Okay. So, let's just do this as like a location. Location is a point to F32. We'll do this as a velocity, which is a point to F32, and the lifetime. Lifetime, which is a U32. And we're going to return, are we going to return anything? Nothing. So this returns nothing. So we're just going to do this. So this is going to set the particle to be whatever it is. So the mesh doesn't change, the location does. So we're going to say self.location equals location. Self.color. We want this to be maybe like setting ourselves to be a new color. Right now, we already have that set, so maybe I don't need to care about that right this second. We can reset that later if we need to. Our velocity, so self.velocity equals velocity, and then our lifetime. So self.frames left equals lifetime. Okay. So now we have this init here. So when we create this, we're fine. I can't use init right off the bat, like inside of here, because we haven't created yet. There's no self yet. So I have to have like something based on like a new one. Unfortunately, this is showing that we want just frames left. If I want to do it exactly like this, then all of these would need to be options, which is not exactly that great. Because I need this to be like an option location. I could definitely do that. It'll just make it a little bit less fun to grab it out. I think for this right now, to give it, we create it, we could go ahead and screen width, screen height. Okay, so let's not do this here. We have our mesh. We're going to create the mesh. We're going to create it in 0, 0. We're going to have our location, and this can just be a location of 0, 0. And it's really just like a filler. A color is red. That's fine. Frames left. We can just set this, like this is a default essentially. And velocity is, we can set the frames left to be 0, so it's dead right away. Our velocity is essentially 0, 0 also. It doesn't, how about it doesn't move when we initially create it, but init here sets this to be whatever we want it to be, and then it will actually do the thing. Okay, init animate in use returns a boolean. Pub function in use. Just self, we are going to return a boolean. And this is pretty simple. Is our frames left equal to 0? So if, actually we could just straight up return self dot frames left is equal to 0. That's it. And that's what we got there now. So if I want to like actually make this as part of like the screen, like on the center of the screen like we had before, we're going to create a new particle and then we need to init it right here. So if I want to do something like that, we need to now make particle mutable. And then we're going to say particle.init. We have to give it a location now. So this would be a 0.2. Unfortunately, we don't have a 0.2 anymore. So we have to bring that back in, or we have to like deal with that. For right now, let's just not worry about it. If I save this, our particle, also you don't need to be mutable if I'm not actually going to do that. Our particle is now going to be in the up left of the screen. So over there. We can see it right here. All right, next up, we have a particle pool. So let's go ahead and create this. Particle pool.rs. Pub struct particle pool. So if I do that, and then we're going to come back to the library immediately, we're going to mod particle pool, and we're going to use particle pool, particle pool. All right, so now we can actually start doing this and get our proper, whatever autocomplete we need from it. So in our particle pool, we are going to have a create, so this is going to be a create particle that's going to like just follow through and create the particle for us. We're also going to have an animate method, which is going to go just run through and call animate on all of our particles. We're going to have a pool size, and then we're also going to have this particles. So inside of here, let's do our pool size first. So we're going to have a const pool size. I think this might need to be a usize. I don't remember off the top of my head. Let's make it like 500 to begin with, because we don't know exactly what it. I guess we'll stay with them. We'll stay with 100 right now, and we'll see what that ends up looking like. So inside of here, we're gonna have particles, which is an array of. It's an array of a particle. So I need to pull in particle. So this is going to be use super to go one level up, and then we want particle. So you're going to be array of particle. And then the number of elements in here is going to be our pool size. And that's all we're storing in here. Then we just have these methods. So we have create, we have create and animate, and that's all. Now, because we have these this particles for particle pool size, we should implement like a constructor for this. Just that way, when we create the particle array, it's it's abstracted into here. We don't screw it up when we're creating it in the main library. So let's implement particle pool, pub function new. We're not going to take anything in. We are going to return a new particle pool. And then this is going to be a particle pool particles, which is an array, but I have to give it, let's see, can I give it, do I have to create them for this. Okay. Expect an array with fixed size of 100 elements, found one with 0 elements. How do I create the new particles? I need to actually do this up here. Let mute particles equals, and then how do I tell it what size to be? I can't remember off the top of my head. You're not unhappy about that yet. Also, we're going to put particles in here. That will figure out what it's supposed to be. Maybe it will know what size it is. I think I have to like tell it that it is pool size. But can I do this? Particle like that? No. Expected value. You mean particle fields? Yeah, I need to like create. Oh, it's gonna clone it. I forgot. We need to create a new particle and then pass it in the context. And what is it gonna do? It returns a result. So because of that, we need to return a game result here. So let's do use GGEZ game result. We also need a context. So we do need a context like that. We need to pass that in here. And then a question mark. So that way we can now do a game result particle pool and wrap OK around this. Now this should be yelling at me that particle is not, doesn't implement the copy trait, because what it's going to try to do is copy this pool size times. So let's go ahead and come back to particle here and just derive copy for it. Derive copy and clone. The trait copy, oh, maybe I just need clone. Oh, the standard, okay, so trait, so copy must be implemented for particle. Note the copy trait is required because the repeated element will be copied. Okay, so what was it telling me? Why can't I implement copy on here? The trait copy may not be implemented for this type on line 7 because the mesh doesn't implement copy. Okay, well let's not hold the mesh in here. I think this will be easier. When I do my draw here, I could pass in the mesh. So we can just say this is a reference to a mesh. And then instead of self.mesh, this becomes mesh like that. And we won't hold you in there. All right, that will make that happier. The mesh, that means we want to hold that inside of the particle pool. So use GGEZ, graphics, mesh, like mesh builder, and all that good stuff. So you're gonna hold a mesh. All right, so new particle. So it's happy about this. Now we need to pass in the mesh. Well, we have that in here. We'll just make this go away. Put you right here. So we create our mesh and put that in right here. All right, we need draw mode and point to. So draw mode off of graphics. Draw mode. Point to off of NAlgebra. Use GGEZ. NAlgebra. Point to. And the color white. All right, so that's everything we need for mesh. So no more errors here. Plenty of errors somewhere else. So what about this? Self-particle draw now takes in a mesh. So I'm gonna just ignore drawing it for right this second because we're gonna have the, we're probably gonna have the particle pool draw all the particles out. And just 25 warnings. That seems fine. So particles, we're not gonna store particle anymore. We're now gonna store particle, the particle pool. So I'm not gonna worry about you, or you, or you. Sort of like back to basics here. Okay, so particle. It's we have its location. Let's see, everything is good here. It's just yelling that it's not being created. Oh, we need to create a oh, we're creating new, aren't we? We don't need this context anymore. If we don't need the context, we don't need a game result. If we don't need the game result, we don't need this okay. And because of that, well, we don't need most of this. Okay, which makes it a lot simpler for you. Particle pool, we don't need to pass in context. And we don't need to question mark that. It just now becomes a particle pool and a new one for there. So we have our particles. You don't need to be mutable because I'm not going to be updating you at this time. And we just store that away. And so now it's just yelling at us that we're not creating our particles. So once we have that, let's store that. So in game state, we're going to have particle pool is the particle pool. That particle pool equals particle pool new, pass it in the context, and question mark semicolon. And in game state here, particle pool. Okay, what's next? We have this create. So create is gonna be creating a particle. So we want to create a particle in the particle pool. So pub function creates, I'm going to name this create particle to make it a little bit easier to sort of understand that I'm not creating a new particle pool. Mute self. And we need to take in the location, so the x and a y where it's going to be, the velocity, and the lifetime. So we're going to have a location, which is going to be a 0.2. Well, we have that here. So 0.2, which is an F32. Velocity, which is a 0.2 F32. And the lifetime. Do we call it lifetime? Yeah. Which is an F32. And however, in this case, we're not going to return anything. Inside of create particle, we're going to find a particle. So loop through all the particles, find one that's not in use. And then init it, which makes it in use again. So let's loop through all of the particles. So for particle in self.particles where it's mutable. Now we need to, so into iterator. Right, an array doesn't have an iterator like a vector does. So we have to do a iter mute to get access to that. So now we have access to a mutable particle where we can now just run if particle dot, I guess it's not, right? So if not particle dot in use. So if it's not in use, then let's go ahead and particle dot init, pass it location, I could have kept that, the velocity and the lifetime, and semicolon. Mismatch types, I expected a U32, found an F32. Okay, so I just need to change U to a U32. There we go. Create particle is existing for us. Oh, right. As soon as we find that one, we need to return. We're done. So this is going to be a return, or I think I can just break, and we are done with this. So I think what this means is that I can just create a particle right off the bat to test with it, or I can do something where I'm like in like our update loop, like just creating a particle constantly. We also have animate, which is going to loop through all of our particles and then run the animate method on it. So pub function animate. We don't need a mutable reference to self, but we do need the context. Wait, no, we don't. Animate, it's draw. Draw needs that. So it just, this one does need mutable reference to self, because I'm mutating the particles in the like each particle in the particles. And I'm not going to return anything. So we're going to do for particle in self.particles.iter mute. And then we're just going to run particle.animate. And there we go. So we're going to animate the particles. And then we probably want draw the particles. So pub function draw self. This one is going to return a game result. All right, so in here, we're going to for particle in self.particles.iter. I don't need iter mute because we're not mutating this, one. And then it's going to be particle dot draw. We have to pass it the context, meaning that I have to take in the context here. Okay, so pass in the context and then pass in a reference to the mesh, which is reference to self.mesh. And then that should be good there. We're going to question mark this and semicolon. And at the end, return OK like that. All right, so that's a nice draw there. All right, then we can create a new particle. So let's see if this works. We'll do this by creating a new particle. So in the library here, let's just create a new particle right away and add it to the pool. So we'll make this mutable. And we'll say particle pool dot create particle. We need to give it a location. So we do need an algebra. So use GGEZ and algebra a point 2. Okay, so point 2 new. And let's give this a, like just, I don't know, 200.0, 200.0. We need to give it a velocity, which is another 0.2. Okay, so 0.2 new. And let's just say this is like 1.0, 1.0. So that should be going down and to the left. And then our lifetime. How long do we want this to live? We'll just say 100 frames. And then question mark, semicolon. What are you upset about? That implements try. Oh, wait, does this not do that? Okay. There we go. All right, that creates our particle. In update, we can now run animate on it. So self.particlePool.animate. And then in graphics, we'll do self.particlePool.draw and pass it in the context and semicolon, question mark, semicolon. No errors, no warnings. Let's see if we created our one particle and then it moves around. Well, I see it up there still in the top left corner. And I don't see it moving. So close. The particle exists. But let's see. In animate, so particle.animate, when we create the particle, we give it the velocity. In init, we set the velocity. In animate, we update it. Did we properly call animate? We did here. Now, particle in use. It's going to call this, well, we think that we know we created the new particle. Actually, those were hundreds of particles, weren't they? So that's not helpful. When we draw them, we only want to draw particles that exist. So in draw, we kind of want to do this only if, so if the particle dot in use. So if the particle is in use, then draw. If I do this, do we get anything at all, or is it just all empty? Okay, there's a particle right there, up in the top left corner. When we create our particle in our main library here, okay, so create particle, our location is a 0.2 new, so 200 by 200. And then we have our velocity, which is 1, and our lifetime is 100. We're also not like making the lifetime go away, so that's a problem. Just out of curiosity, if I don't have this, I shouldn't see anything on the top left. I do, okay, so I'm not doing Something's wrong. Or I did something wrong. Okay, so we initialize the pool. When we initialize our pool and we create all of these new particles, we have frames left is 0 to begin with right away. In use, self.frames left is equal to 0. This should be greater than 0. That's a problem. They're all in use. So when I try to create the new particle, that didn't work. Okay. Let's try this again. There we go. There's our particle, our one particle in the entire particle system, and it's properly moving. Excellent. And if I want to create the particle every single frame, I can do this here. Instead of particle pool, we have to do self.particle pool. You don't need to be mutable anymore. We're now just going to be creating a particle every single frame. And then we're going to get a limit of them, right? Like we can only create so many of them before it ends. So that is that. And if I want to give it a, in our animate, so in particle animate, we also want to say self.frames left minus equals to 1. Now, if I do this, I can only, let's see, in frames left, is it animating? We should only animate this if they're alive. So if particle.inUse, then animate this. Otherwise, we're going to get an underflow as we try to go below like below 0. So if we do this, now our particles should continue a stream. Yeah, they come to here, they die, and then they get recreated. So now it's like just recreating over and over and over again, and that's fine. If I want to now put this, like start it into the center of the screen, that's pretty simple. Here in our location for when we start them, let's actually figure out what the center of the screen is. And we can just do that one time. So we can just say center of screen is a 0.2 F32 and calculate that right here. So that center of screen equals 0.2. New, we actually need to grab, so that screen width, screen height. Good morning, Chantilly, equals graphics, drawable size, hand it the context, and inside of this point, we can now do screen width divided by 2.0, screen height divided by 2.0. Now we're going to be copying this over and over again, but at least it's created already. So we have center of screen, and now we can use, instead of this 0.2, we're going to do self.center of screen. Center of screen, so 0.2s implement clone and drop, so that will like just automatically work for us already. Our velocity is going to be 0, 0 to begin with, and I think that's fine. Let's run this. Now our stream should start from the center. All right, there we go with that. Let's also make it go in like random direction, which should be pretty simple. Let's just bring in rand here. So rand equals, in our main library, let's pull in rand and like store it. So use rand prelude star. And then we're going to pull in RNG, which is a thread RNG. And let's go ahead and create this. Let's let RNG equals rand, let's see, what is that? Thread, what? I can't remember. Thread range? Yeah, thread range. That's it. That creates RNG, and we'll store that. And now here, when we create a new particle pool, when our velocity, we're going to do our RNG self.rng dot gen range between -1.0 and 1.0, and then our y. Wait a second. This is in 0.2 new. Self y. Okay, so you are going to be the self dot RNG dot gen range between -1.0 and 1.0, like that. All right, what did I do wrong here? So 0.2 new. This might be easier to like create this outside of here. So let's do let velocity equals, it's going to be u. Oh, I think I know what I did wrong. Okay, so our 0.2 new, our x is going to be here, so self.genRange, like that. Our y is going to be here. And then close this off. That gives us our velocity, which then can be used right here. So it's going to be a random velocity for every single particle that we create. Bare Knuckle Waffle throws a box of semicolons in the air and runs away. I know, semicolons everywhere. All right, so we have that. We then animate them. They'll be going off in different directions now. Let's try that. So now we have our particle system that's just like creating these and they're spreading them all around. So that's pretty cool. That's a nice look for this. I'll put this, I don't know, right there. Now, what if I want to make this random colors too? Well, we can do that, right? We can say that when we create our new particle, when we init this, we want to also choose and take in a color for this. So we can say a color is a color and do virus spreading. Yep. Self dot color equals color. All right. So that's going to be used for that. And now in our particle pool, we're going to pass this through. So create particle. We're going to take in a color, which is a type color. I don't have that in here, so I need to know what the type is. And pass that in here. Okay, and then finally back into the main library here, let's create a random color as well. So let random color equals, this is gonna be a color. We need to know what that type is. So under graphics, We also need color. Scale the color based on distance from origin. Ooh, that could be interesting. So let's do color new. All right, so now we're gonna have our R, G, and B. So we're gonna do this as self.rng.genRange between 0, 0.1, 0.0, and 1.0. Yeah, I don't know how to do like scaling with colors with RGB. If I had like a hue, that would be a lot easier. But I don't really know how to do it properly with this. I can do, we can scale the alpha. That might be good to do. But yeah, I don't know how to do like math with RGB properly. See self.rng.genRange. This is actually going to be, hold on, let's just copy paste that twice. We do want to have this be 1.0 for the alpha. Semicolon down here, and then after the lifetime, we'll pass it the random color. Okay, no more errors. Let's go ahead and close this and do it again. And so now we have a random color just sort of like popping out. So that's also pretty cool. Something that we can do here is we could create, we can make it like fade away over time. To make it fade away over time, we need to set the alpha needs to be set. And I think we can do that over the particle as we draw it with the draw params. I think there's things that we can do with this. Is there a link to the documentation? So .dest, .color, is there? There's a scale, so I can like scale it down and have it sort of disappear that way. I can do another color. Oh, I don't know if I can do a to like change the Actually, wait a second. No, because when I change that, it is setting the color. Let's have it scale down. That will make a little bit more sense. So if I bring in a scale, I think that's off of graphics. Yeah, scale. I want to uniformly scale this based on the frames left and like the start frames. So if we figure out like, okay, like how long we were living. Ooh, you have a code pen for me. Let's take a look at that. Oh, you have a fading algorithm in RGB. Okay, so let's take a look at this. So your color starts with RGB 255. Background color. Let's see, set interval. The red goes away and the green goes up. Okay, so if red is greater than 0 and blue equals to 0, red minus minus, green plus plus. Okay. I think I can do this. Let me put this here for a reference. In our particle, so I think in that case, we want to go back to everything starting as red, don't we? What is this? In our main library, we're not going to have a random color anymore. We don't need that. We don't need you. Particle doesn't take in a color. Doesn't use that color. Particle, you're not in init. We don't take in a color. We don't set that, which means, okay, we're setting with our red here, and we're setting our color. So there we go. We're starting with red. Then in our animate here, we're going to be doing this update. So if red is greater than 0, we need to store RG and B separately and then create the color every single frame. So we don't even need the color here to begin with. We don't need to store it. Instead, what we need to do is store red is an F32, green is an F32, blue is an F32. So let red equals, so we're going to start with 1.0. Let blue, green equals 0.0. Let blue equals 0.0. Okay, so then we'll have red, green, blue here. When we draw, we're going to grab the color. So that color equals, and we have to create the color from here. So it's going to be color new from self.red, self.green, self.blue. And so instead of self.color, it's just going to be color like that. What are you upset about? Oh, and then 1.0 to make sure it's full alpha. And then down here in animate. So here's where this magic happens. So we want to, if the red is greater than 0, okay, so if self.red is greater than 0.0, and self.blue is equal to 0.0, then red minus minus, so self.red minus equals 0.1. You want to interpolate from your start to end color. Oh, sort of like, okay. So 0.1. I don't know if this is gonna be too fast. We'll see. And like maybe this needs to be like 0.01. And then green, so self.green plus equals 0.01. This is a separate if statement. So if, it's not an else if self.green is greater than 0.0 and self.red is equal to 0.0, then self.green minus equals 0.01, self.blue plus equals 0.01. Then finally, if self.blue is greater than 0.0 and self.green is equal to 0.0, self.red plus equals 0.01, self.blue minus equals to 0.01. And then that should change our color over time. We have no errors, but 6 warnings. So unused color. Let's go ahead and see if this works really quickly. Hey, and there we go. It's sort of like they're all changing. Now they're all changing over time. So I would need to they just went to green and they're never going anywhere else. It's close. I've got something wrong with it. Because if we take a look at yours, it's like going back and forth. So I'm missing something. Yeah, I'm really close with it. I'm just not quite there. And so I put this in particle, right? Yeah, so like if for some of these, like self.red minus equals to the self.green. And I'd want to do like the math to determine like, okay, to make this last, like to go between 0 and 1 in the time that our lifetime is. Like I probably want to like figure that out and do all that math for that. So if I make this a lot slower, we like make this a globe, like a constant, so that way we can like just update and tweak these numbers really easily. Then they just sort of, oh, now it's too slow. Oh, they all change over time because when I'm reinitializing them, they're not resetting their color back to red. Okay, so let's change this back to this. And then in init, I want to say self.red equals 1.0. Self.green equals 0.0. Self.blue equals 0.0. And now they'll all start green, or they'll all start red and change over time as they head out. Okay, so that's sort of like what we were going for. And we'd have to tweak like we could tweak the lifetimes, make them live a little bit longer. The way we do that is come over here and just say, you know what, your lifetime is an update. Instead of 100, maybe we'll say here something like you live 500 frames. And now it'll last a whole bunch longer. And notice we actually run out of particles before we like create the new ones. So, you know, this is where we maybe want to increase our particle pool. Maybe we want to have a pool size of like 500 instead. This slows the computer down a bit, so let's actually try running this in release mode, which should make it a lot smoother, a lot better. But yeah, particles can do that. Anyways, this has been implementing the particle pool in Rust. I wasn't sure if I was gonna be able to get through this in one stream, but we were able to. So that means tomorrow morning, we're gonna be moving on to the last chapter, which is gonna be a lot of fun. So I'm gonna let this run, and then I'm gonna end the stream. But if any of you have any questions, please ask. I'll be happy to answer. Building for release always takes extra time because it's doing all those optimizations behind the scenes. So you can almost imagine if we could use like images, it wouldn't really matter. It'd be the exact same thing. And so here we go. looks like we're just creating them forever. And we can see that some of them are just disappearing around here. And then they're being recreated. So this is perfect. I'm not trying to make it stop at green, but my math is somehow wrong on this particle for the for here. As I was sort of like moving through this really quickly, and it's probably, you know what it probably is? It's never actually reaching exactly 0.0 because they're floating point numbers. I should probably do something where, like, if self.green is like less than 0, have it reset or do that. We'll have to figure that out. Anyways, I don't have time, unfortunately, to go through that. So I do have to get ready for the rest of my day. I'm gonna go ahead and quit this, close you out, close all of you down. Let's open up Git Kraken and send this code on up to GitHub. So cargo lock, toml, library RS, main particle and particle pool. This is all good. Particle pool in Rust and GGEZ. Push that on up, and you can see all of this with Bang repo. Yeah, I know. That's probably right. Unfortunately, I do have to go. If you want to try it, that's the location to the code, and I would be happy to accept a pull request if you want to pull that in. But with that, I am done for the day. So